In the spring of 1913, the age-old question, what is matter made of, was fresh on the mind of Niels Henrik David Bohr. And the young Dane's answer, fresh to the point of being revolutionary, was a model of the hydrogen atom. His work was pivotal, a turning point in theoretical physics. But by all that was holy in those days, Newton's mechanics and Maxwell's theory of electromagnetism, it couldn't possibly be right. Nonetheless, his ideas were brilliantly conceived. In the first place, Bohr adopted a model of the atom that resembled the solar system in miniature. A heavy positive nucleus took the place of the sun, and like a planet, an electron was set into orbit around it. But while a planet is attracted to the sun by the force of gravity, the electron is attracted to the nucleus by the force of electricity. So in spite of the difference between the two, both had forces of the same basic 1/r² form, and both would have the same kinds of orbits. As Johannes Kepler had observed, and Isaac Newton had explained centuries earlier, those orbits would be ellipses, or, depending on their eccentricity, possibly even circles. To simplify matters, Niels Bohr assumed atoms would have circular orbits. In a circular orbit, the potential energy is -d/r. And the kinetic energy is positive, but half as big. So the total energy is -1/2 d/r, whether for a planet or for an atom. Since this seemed to be the very model of a Newtonian atom, what was the matter with it? In other words, how had this upstart violated the physical laws of his day? And if in fact he really had, why didn't all right-thinking physicists dismiss his ideas on the spot? Perhaps because at this point, young Bohr was still on solid ground, which made his work worth a second glance. And that's when the problems became obvious. Being radical, Bohr had gone further, far enough to propose that an electron could exist only in certain orbits, which was contrary to Newton's laws. Then, contrary to Maxwell, Bohr said the electron would radiate or absorb energy only when it jumped between these definite orbits. Those proposals were more than merely contrary. In fact, in the world of physics, they were totally against the law.